Greetings students. In today's lecture we are going to see about types of implantable hearing aids. You can also call it as classification of implantable hearing aids. The implantable hearing aids are classified into middle ear implants and bone conduction implants. The middle ear implants are further classified as passive middle ear implants and active middle ear implants. Here the classification of passive middle ear and active middle ear implants depends upon how the implant is going to conduct the sound. Okay. In passive middle ear implants, there is not going to be any reinforcement to the incident sound, which means the incoming sound is just conducted. There is no amplification of the incoming sound. Whereas in active middle ear implants, whatever sound is picked up by the microphone, it will be amplified. Then the amplified vibration will be sent to the output transducer. Such kind of mechanical circuits or electrical circuits will not be available for passive middle ear implants. The bone conduction implants are classified as passive bone conduction implant as well as active bone conduction implants. For any bone conduction devices, we require a vibrating transducer. This vibrating transducer in passive bone conduction implant does not have direct contact to the bony parts of the patient. Whereas in active bone conduction implant, the vibrating implant will have direct contact with the bony parts of the patient. It's surgically placed on the bony part of the patient. The active middle ear implants are again classified into partially implantable, where a part of the device will be seen outside, will be placed externally. Only a part of the device will be implanted surgically. Whereas in fully implantable hearing aids, all the components will be completely surgically implanted. None of the component will be seen externally. So moving on to more details of passive middle ear implants. These implants will be done during the tympanoplasty surgery. So during the tympanoplasty surgery, there might be some changes in the anatomical structures of the middle ear. So to replace those missed anatomical structures, we can use passive middle ear implants. So in type 2 tympanoplasty and type 3 tympanoplasty, the ossicular chain is being disturbed. In such conditions, whenever there is an incus replacement, it is called as type 2 tympanoplasty. There will be a restructuring of the tympanic membrane. Malleus will be intact. The incus will be replaced by an implant. So that is type 2 tympanoplasty. In type 3 tympanoplasty, we have two varieties. One is called as partial ossicular chain replacement prosthesis. The other one is total ossicular replacement prosthesis. In partial ossicular replacement prosthesis, the malleus and incus is replaced by the implant, whereas the stapes is intact. In total ossicular replacement prosthesis, malleus, incus and part of stapes is replaced by the implant. The footplate of stapes will be intact. Moving on to the active middle ear implants. These active middle ear implants are classified into partially implantable hearing aids. These partially implantable hearing aids will have a part of this component seen externally. It will not be implanted. Another part of the component of the hearing aid will be implanted. So it is partially implantable hearing aids. Fully implantable hearing aids, all the component of the hearing aids will be totally implanted inside the patient. Nothing will be seen outside. So examples for partial implantable hearing aids are cochlear middle ear transducer, Autotronics Maxim, Cochlear's Kodak, Rheon device, Medals, Vibrant Sound Bridge. These devices are partially implantable hearing aids. Whereas in fully implantable hearing aids, the examples are Cochlear Carina, NY Esteem and Implex totally implantable cochlear amplifier. Moving on to the bone conduction implants. These bone conduction implants are classified as passive and active. So in passive, this is an example of Baha device. The vibrating transducer is going to be over here. So it has a microphone, processor, amplifier and the vibrating transducer is going to be over here. And this is the bone, the skull bone. This is a soft tissue and skin. So the vibrating transducer does not have direct contact to the implant or the bone. So it is called as passive bone conduction implant. Whereas in active bone conduction implant, what happens is that the implant through abutment will have direct contact with the vibrating transducer. So the bony part and the vibrating transducer are in direct contact with each other. The soft tissue is not going to hinder the vibration. Whereas in passive bone conduction implants, after the transducer there is a magnet, skin, layer of skin, soft tissues, another magnet, then comes the implant. So this is the difference between passive bone conduction implant and active bone conduction implant. The examples for passive bone conduction implants are Baha Attract, Sofno, Alpha. Whereas the examples for active bone conduction implants are Baha Connect, Oticon Ponto, Oticon bone conduction implant BIST transducer, Medal bone bridge. The implantable hearing aids can also be classified based upon the type of transducer being used in those devices. So they are classified into electromagnetic transducers, which means the transducer will have a magnet and a electromagnetic coil. So whatever output comes from the amplifier in electrical energy will be transferred to this electromagnetic coil. So when electrical energy travels through a coil, it generates magnetic field. That magnetic field will vibrate the magnet. So that is electromagnetic mode of transduction. The other type of transducer is electromechanical, which means electrical energy is given to the transducer and the output will be going to be vibration. So here electrical is converted to magnetic field, then vibration, whereas here in electromechanical the electrical energy is converted into mechanical energy. So the output from the amplifier will be in electrical form will be delivered to the transducer. This electrical energy will be converted to mechanical energy, vibration, and that will be given to the ossicles. The third form of transducer is piezoelectric crystals. So these crystals have a unique property of generating the electrical energy. So whenever these crystals are distorted or compressed, it produces electrical voltage. Or whenever an electrical voltage is applied to these crystals, they change their shape. So example for electromagnetic transducers are Vibrant Sound Bridge and Autologix middle ear transducer. The examples for electromechanical transducers are Vibrant Bone Bridge, Baha. Any bone conduction implant will come under this electromechanical transducer. Example for piezoelectric crystals transducers are NY-ST. So these are the references used for this particular lecture. I hope that classification is much more clearer now. Thank you.